here I am. We are talking about polynomials and the big idea. What's the big idea for this week? We're going to talk about polynomials. What's the polynomials? Well, polynomials talk about several things that include, hang on one second. Polynomials have, let's see, several terms. Terms are separated by addition and subtraction. Subtraction, terms. Those are things that are separated by terms, or things that are separated by addition and subtraction. Polynomials have several polynomials, or sorry, several terms. Several terms in the form of x to the nth power. Some a number could have a sign in front of it, could not have a sign in front of it. There's no sign in front of it. We assume it's a positive. The x to the nth power is also the term, is part of the term. So there's a polynomial. What's the big idea? Well, we have to, a polynomial could be something like this. X squared plus, ugly too. X squared plus 3x plus 4. That might be a polynomial. Sometimes it's got parentheses around it, sometimes not. Polynomial might also be something like x to the third power. That's a polynomial of just one term. Here's a polynomial of three terms. Three terms separated by addition and subtraction. Big idea, there's a polynomial. Terms are separated by addition and subtraction. Could be also x to the third power minus x squared plus x minus 4. This minus x is also a term. The term is negative x squared. So those are terms separated by addition and subtraction. There's no sign here, so we assume it's positive. So terms are inside polynomials. Polynomials made up of terms. Terms include the sign in front of them. All right. What would it do with any system? If we've got a system, we talk about adding, subtracting, multiplying, dividing, and equations. Equations probably is going to come in later. We'll probably talk about polynomial equations later. And in fact, add and subtract, you can talk about those in the same breath because they're essentially the same function. Same function, meaning adding means moving to the right on a number line, subtracting means moving to the left on a number line. But either way, it's the same function in different directions. Multiply and divide, same function, just different directions. So if we're talking about multiplying and dividing, same function, but different direction. We'll talk about adding and subtracting. What's the big idea with adding and subtracting? If we're adding and subtracting, hang on one second. That one, move that over please, thank you. If we're adding and subtracting, all you have to do, because remember, add, subtract, same function. What we have to do is combine like terms. And that's what adding and subtracting is. Remember, terms are separated by addition and subtraction. So if you've got combining like terms, we just combine like terms by adding and subtracting. So if I've got something like x squared plus 3x minus 2, and I'm adding, hang on, I'll do a different color, adding another polynomial, x squared plus 4x plus 7. If I'm adding this blue polynomial to that green polynomial, all I'm doing is combining like terms. Remember that if there's a plus this polynomial, we imagine that there's an invisible 1 right here. And then we distribute the polynomial, distribute that number and the sign across the parentheses to get a simplified term of x squared plus, or a simplified statement. Same first polynomial plus second polynomial is plus 1 times all these terms plus x squared plus 4x plus 7, because all we're doing is adding or multiplying a positive 1 times everything over here to get our terms. And now we just combine like terms. Like terms have exactly the same variable to exactly the same power. We combine x squared and x squared. 1x squared plus 1x squared gives me 2 x squareds. Plus 3x plus 4x gives me plus 3 plus 4 plus 7x. Minus 2 plus 7 gives me a plus 5. And that would be adding polynomials. And that's all we do, combine like terms when we've got adding polynomials. If I am, hang on one second, see if I can, if I'm subtracting polynomials, go over here, add polynomials, subtract polynomials. Same idea if we're subtracting polynomials, but we've got to pay attention to one extra thing. if I've got subtracting polynomials, again, subtract polynomials, all we have to do is take a look at x squared plus, and I'm just throwing out numbers here, x squared plus 3x plus 2 minus all of a second polynomial, x squared plus 2x plus 7. I've got to imagine as well. I'm going to, again, adding and subtracting polynomials, combine like terms. Terms are separated by addition and subtraction. Terms are separated by addition and subtraction. But now I've got to pay attention to the fact that I've got that invisible 1 out here that I've got to distribute across the parentheses. So what happens to my x squared plus 3x plus 2? X squared plus 3x plus 2 stays the same because it's not really changing. We're subtracting this polynomial. That means we've got to multiply this negative 1 times everything inside the polynomial. Negative 1 times positive x squared, negative x squared. Negative 1 times positive 2, negative 2x. Negative 1 times positive 7, negative 7. And now, after we've cleared out this subtracting of parentheses, all we have to do is take a look at combining like terms. X squared, 1x squared, minus x squared minus 1x squared is, you could put it as 0x squared, but we could probably just throw it away because 0 times anything is 0. So x squareds go away. Plus 3x plus a negative 2x, 3 minus 2, 1x, or just x. You could put the invisible 1 there if you wanted to. You could also put the probably invisible plus sign there if you wanted to. But these invisible things aren't really necessary. Positive 2 and negative 7, minus 5. And there's our answer to x squared plus 3x plus 2 minus all of this polynomial. Combining like terms, there's our answer. We combine like terms after we get rid of that minus parentheses. Next idea is if we're multiplying and dividing polynomials, well, a couple things. Number one, we're not going to divide polynomials, not here, not in this situation. So dividing, that'll come in maybe in rational expressions or maybe rational equations. But for right now, we probably will not divide, maybe by a monomial. But essentially, if we're multiplying a polynomial, pay attention to signs, numbers, and variables. Because all we have to do is take a look at a couple different things. Number one, if I've got something like 2x times another monomial. It's a monomial, one term, times a monomial. Let's say it's 4x. I have to do a multiply the signs, positive times positive. Both of them are invisible positive, so we got an invisible positive sign. 2 times 4 is the numbers. Take a look at multiplying the signs. Then multiply the numbers. 2 times 4, 8. Then multiply the variables. X times x to the first power times x to the first power is x to the 1 plus 1 power is x squared. So there's our answer for multiplying a monomial times a monomial. And really multiplying polynomials breaks down to always a monomial times a monomial. Taking a look at multiplying signs and numbers and variables. So if I've got something like, hang on one second, alright, if I've got a monomial times a polynomial, 2x times 4x plus 3, I break it down to a monomial times a monomial. And then that 2x times 4x becomes my first term, and we take a look at signs and numbers and variables. Positive times positive, positive. Invisible positive, we'll write it out here. 2 times 4, 8. X times x, x to the invisible 1 times x to the invisible 1, x to the 1 plus 1, 2 power. The second term is 2x times positive 3. And again, second term is positive times positive. Remember, look at signs, look at numbers, look at variables for every monomial, because every polynomial times a monomial, or polynomial times a polynomial, breaks down to a monomial times a monomial. The second term becomes positive 2x times positive 3. So signs, positive times positive, positive. 2 times 3 is the numbers, 6. X times invisible 1, x. And there is our answer for multiplying a monomial times a polynomial. Polynomial times a polynomial means you've got another term out here. And you just multiply the 2x or whatever you've got here by everything inside. And whatever term out here multiply by everything inside, breaks down to a monomial times a monomial, and this is our idea. Signs, numbers, and variables is what we have to pay attention to when we multiply a monomial times a monomial. Any questions, let me know. You can also you can always contact me through my daughter Bridget or Mr. Barrett. Mr. Barrett's got all the answers as well.